Here are the solutions for week 8. We have lessons 10, 11, and 12 to go over. So the first one here, this quadratic function f is given, and without graphing, we want to identify the x-intercepts of the graph of f. So, and explain how we know. So in factored form, the x-intercepts are easy to find because when we have two factors multiplied together and the answer is 0, one of them has to be 0. And that's what we're looking for here when we talk about x-intercepts. Y is 0 when we cross the x-axis. So our y-coordinate is 0. So we're going to set this equal to 0, these two factors equal to 0, and figure out what values of x would make each of these a 0 so that when we multiply them together, we get 0. So for the first one, if we just use x minus 7 equal to 0, that tells us that x is equal to 7. And so our point, one of our x-intercepts, is 7, 0. The next one, if we set x plus 3 equal to 0, subtracting 3 from both sides, we get x is equal to negative 3. And so our other x-intercept is going to be at negative 3, 0. So those are our two x-intercepts, and showing the work here is how you can explain how you know. So now we want to expand this and use that form, the standard form, to identify the y-intercept, because on the y-intercept, x is 0. So we're looking for points that start with 0. So instead of letting y equal 0, like we let the f of x equal 0 here, we're going to let x equal 0 in both of those cases, and or in that case, and figure out what y is. So we can use the diagram method, or you could use your distribution skills, whichever method you choose. I'll put it in diagram here. We're going to multiply x minus 7 times x plus 3 using a grid. So I'll just put x minus 7 along the left and x plus 3 across the top. That way I get x squared minus 7x, and then plus 3x goes here, and minus 21 goes there. And then remember, those two diagonal terms are always like terms. And so when I combine them, I'll have f of x is equal to x squared minus 4x minus 21. And then when I find f of 0, because x is 0, when I'm looking at y-intercepts, I get 0 squared minus 4 times 0 minus 21. So it's always that constant term. When you have it in standard form, that will be your y-intercept. So at 0, negative 21, that's where the graph crosses the y-axis. And you can always put either one of these forms into your Desmos app and check your work on those too. Number 2, what are the x-intercepts of the graph of the function defined by x minus 2 times 2x plus 1? So again, we're looking for x-intercepts, so y is equal to 0. And so if y is equal to 0, my function f of x, remember f of x is the y, that means that one of these binomials, one of these factors in factored form, has to be 0 in order for us to get 0 here. So we'll set each of them equal to 0 and find out our two x-intercepts. So x minus 2 equal to 0 tells us that x is equal to 2, and so one of our x-intercepts is 2, 0, so these two are out right away. And the other one is when we set 2x plus 1 equal to 0, subtract 1 from both sides, and we get 2x is equal to negative 1, and then we would divide by 2 on both sides. So we get x equal to negative 1/2, which then that x-intercept would be negative 1/2, 0, and that's this one then. So this one doesn't work. All right, I'll get rid of some of this work here and move on to number 3. Here's a graph that represents a quadratic function. So which expression could define this function? So let's look at the x-intercepts because we've got factored forms down here. And this will be easy for us to track, or to compare. This x-intercept has coordinates -1, 0, which means that x plus 1 must have been a factor, because if I set x plus 1 equal to 0, I get x equal to -1. So this tells me that I have one factor of x plus 1. So this is out, and so is this. And then this one over here, this x-intercept has coordinates 3, 0. And so that tells me that x minus 3 must have been a factor, because when I set that equal to 0, I get x is equal to 3. And so x plus 1 and x minus 3 would be letter C here. And now we're on to lesson 11. Lesson 11 says select all true statements. So look for more than one here about the graph that represents this function, 2x times x minus 11. So this doesn't look like the other ones with two binomials, but you can think of it as two binomials just the same. So minus 0, though, doesn't really do anything for us. But if I would set that factor equal to 0, I get x equal to 0. So 0, 0 is one of our x-intercepts. So I can cross this one out and this one. Setting x minus 11 equal to 0 would give me x is equal to positive 11. So this letter B is the best choice for x-intercepts. It only has one x-intercept. No, we just found that it has two. Now the coordinate of its vertex is -4.5. Remember, we can find the x-coordinate of the vertex by taking the average of the two x-coordinates of the x-intercepts. So if this graph goes through 0 and 11 over here, so the vertex of the x-intercept is going to be halfway between those two. So if we just add them together and divide by 2, we'll get the x-coordinate of the vertex. So 11 plus 0 divided by 2 is 5.5. 11 plus 0 divided by 2 is 5.5. And so that's how you find the x-coordinate of the vertex, if you know each of the x-coordinates of the x-intercepts. So these ones are out. Number 2, select all equations whose graph have a vertex with x-coordinate 2. So if there's an x-coordinate of 2, it means that there must have been a factor of x minus 2, because when I set that equal to 0, I get x is equal to positive 2. So we're just going to look for those that have a factor of x minus 2. So the first two do, and that's it for that one. Number 3, again, we're going to identify x-intercepts and then x-coordinate of the vertex. So my two x-intercepts for this first one, set that equal to 0, and then set this equal to 0, we get 0, 0, and 2, 0. And halfway between those two x-coordinates, 0 and 2, I would take 0 plus 2, divide by 2, and so the x-coordinate of the vertex is 1. Down here in the next one of my x-intercepts is at x equal to 4, so that would be 4, 0, and this one tells me that x equal to -5 would be the next x-intercept. So when I add these two numbers together, the 4 plus the -5, and divide by 2, to find halfway between them, I get negative 1 divided by 2, which is negative 0.5. The next one, remember if it's a monomial like that, just x is equal to 0 is one of the x-intercept, and this one tells me that x equal to 3 is the other x-intercept. So I have 0, 0, and 3, 0. And halfway between those two x coordinates would be 0 plus 3 divided by 2, which is 1.5. 1.5, 3 over 2. Number 4, which one is the graph of the equation x minus 3 times x plus 5? Let's see here. So we have x-intercepts at 3 and negative 5 based on that factored form. So 3 and negative 5, this could be it. Looks like that's it. So this would be graph C. Oh, here. And now we're on to lesson 12. Here are 4 graphs, match each with a quadratic equation that represents it. So here we have, well, let's see. We know that this one has a y-intercept of 5. This one has a y-intercept of 7. And this one has a y-intercept of negative 3. So 0, negative 3. We can tell all of this from standard form. And this one looks like it has a y-intercept then of 0 because there is no constant term. So just going by y-intercepts alone, graph A would be this one because it goes through the y-axis at negative 3. Graph B has a y-intercept of 0, so I'm going to match that one up with number 1. Graph C has a y-intercept of 7, so that would match with number 3. And graph D has a y-intercept of 5, so that would match with number 2. So number 2, the two equations y equals x plus 2 times x plus 3 and y equals x squared plus 5x plus 6 are equivalent. Which equation helps find the x-intercepts most efficiently? I'm going to go with the x plus 2 times x plus 3 because you can tell it's sometimes just by looking at them after you've done a few what your x-intercepts are. And which equation helps find the y-intercept? Well, it's easier to put 0 in for x in this form and just right away that that's your y-intercept. Number 3, here's a graph that represents y is equal to x squared. On the same coordinate plane, sketch and label the graph that represents each equation. So x squared minus 4 would be the same shape, just move down 4 units, which that's not very good. And negative x squared plus 5 would be flipped over and going through, I should put that in a different color, and going through 5 on the y-axis. So that's that one. And A is the blue one. Number 4, select all equations whose graphs have a y-intercept with a positive y-coordinate. So, yeah, this one does not. So why am I circling it? This one has a y-coordinate of 0 of negative 2. So that's not a positive y-coordinate. This one has a 0, 0 y-intercept, and so that's not considered positive. This one, if we multiplied x minus 1 times itself, which is what that means, if we expand this out, when we multiply, we get, if we do use our distribution property, we have x times x is x squared, x times negative 1 is negative x, negative 1 times x is negative x, and negative 1 times negative 1 will give us a positive 1. So this gives us x squared minus 2x. These two combine to give us minus 2x, and then plus 1. So this is a positive y-intercept because it has coordinates 0, 1. So we can circle this one. That's out because the y-intercept there would be negative 5. And for letter E, again, if we expand this out, we have x plus 1 times x plus 2. X times x is x squared. X times 2 is 2x. 1 times x is x. And 1 times 2 is a positive 2. So that's going to be a positive y-intercept, because if I put 0 in for x, I get a positive 2 for y. So these two that we had to expand out will give us y-intercepts with a positive y coordinate. Number 5, describe how the graph of the absolute value of x has to be shifted to match the given graph. Write an equation for the function represented by the graph. So this one is from lesson 4, and we're not going to do that one, or unit 4. We didn't do those. And let's see, here's a graph of the function, and we're going to skip that as well. So we are done. I will make sure those two problems come off of your assignment. And that's it then. I hope this helped. Thank you.